All right, DI 62-1. First, it says use the rational zeros theorem to make a list of all possible rational zeros. So with our function, we need to do all the list of p's over q's. So the factors of this number are the p's. Factors of your coefficient here are your q's. So the factors of 6 are 1, 2, 3, and 6. The factors of q are just 1. So now you have to do all the combinations. So like 1 over 1, 2 over 1, 3 over 1, 6 over 1. So these are a list of the possible rational zeros that would work in my polynomial. Let's look at number 4. It says find the real zeros of the polynomial using the techniques learned. So I just need to list what the real zeros are. So once again, x cubed minus 2x squared minus 5x plus 6. So using those rational zeros theorem, the p's over q's, we said plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I need to use this to find that. So let's start testing them. 1. You write all the coefficients. Multiply, add, multiply, add, multiply, add. So it worked. So I have a 0 that works is going to be 1. Working backwards, remainder constant. So I have x squared minus x minus 6. Well, this will factor into x minus 3, x plus 2. So those are my other zeros. So my zeros are going to be 1, 3, and negative 2. Now, if I was asked to factor it completely, I would write it as x minus 1, right? X minus your 0, and then x minus 3, and then x plus 2. It says create a polynomial which has desired characteristics. You may leave the polynomial in factored form. So it says the solutions to p of x equals 0. So it says the zeros are plus or minus 3 and 6. So far I have x minus 3, x plus 3, and x minus 6. So those are my zeros. It says the leading term is 7x to the 4th. Ooh, that's good. So that has to be a 7, but notice so far I don't have a I only have 3 zeros here. Well, it says I need to have 4 because it says x to the 4th. So maybe I'll make that squared. And then it says the point -3, 0 has to be a local minimum, which means it wants that value to have that U shape. So maybe I don't make that x minus 6 a squared, because if I did that, then that would become a local minimum because it's going to bounce at that value, right? So instead, the point -3, 0 is going to be here. I would want to make that squared. And so that's going to be my polynomial. Number 8, it says find the real zeros and state its multiplicity. So the real zeros are -5. I have 2 of them, so multiplicity 2. 3, multiplicity 4. Super easy. Now it says using the in behavior, sketch a graph. So right here, x is my leading term. I have 2 of them, so I have x squared so far, times, and then I have x to the 4th, so times x to the 4th, and so that's going to give me x to the 6th. Well, the in behavior means that they're both going to go up like that. So now sketching my polynomial, for the y-intercept, I'll just say it's going to end up being positive, but it's going to be somewhere up there, just to save some time. And so I have -5 and +3. And so it's going to bounce because my multiplicity is even. It's going to bounce because my multiplicity is even. And that's going to be my answer. All right, it says find the exact value or state what's defined. So number 10 says arctangent of tangent. Well, tangent has to be between -π² and +π², but it can't include -π² or +π². So even though the arctangent and the tangent cancel out, tangent can't be at π², it's undefined. Number 11, arcsecant of secant. Well, those are inverses of each other, they cancel out. So you are left with pi force. Pi force is within the range. It's between 0 and pi for secant, so it works. So that's one of my answers. And then for number 12, you're going to use SOHCAHTOA to be able to find the missing side.